So this is the second part of section 5.2. There is going to be a third part of section 5.2, which we'll deal with on Monday. We're still going to be working with dividing rational expressions today, but it's going to be a little bit different. I already talked a little bit about dividing rational expressions earlier today, but this is the difference. Today we're going to be focusing on dividing monomial radical expressions. What does that mean? It means there are not any pluses or minuses. We're going to be dividing things like root 84 divided by root 2, or 3 root 8 divided by 2 root 3. And then we're also going to be doing something which is called rationalizing denominators. And it turns out, and when the time comes, when the time is right, I'll explain why. It turns out we just never want answers with square roots in the denominator. Okay. There are a couple of reasons for it, but we'll talk about them later. So to begin with, what I'm telling you is we have a similar rule for division of radicals that we had for multiplication. When we multiplied radicals, when we multiplied radicals, we are allowed to multiply coefficients by coefficients and radicals by radicals. And when you multiply the radicals, you multiply the radicands, the numbers underneath. And we demonstrated that to be true yesterday. I'm telling you the same thing is true when we divide. So if I said, how can we write the square root of 352/17? We can write it as the square root of 352 over the square root of 17. Let's just demonstrate this on our calculator. Let's calculate. I would like you to do this for me. Let's use our calculator and calculate what the square root of 352/17 is. And then we're going to calculate what the square root of 352 divided by the square root of 17 is. When we calculate the left part of the screen, that's how I enter it in my calculator, and what I end up with is about 4.55037. It's an irrational number, so this is a decimal approximation. If I were to calculate the right-hand part of the screen, I would have the square root of 352, and I have to close the brackets on that argument, on that thing I'm operating on, which is called an argument, divided by the square root of 17, and you get the same number. Now, I can't prove to you that the decimals are the same to infinity, but I'm not here to mess with your mind. The numbers are the same, okay? So this is the rule we have. Let's start off with some fairly easy examples. What is the square root of 960 divided by the square root of 120? Well, the square root of A over the square root of B is equal to the square root of A over B. In other words, we're allowed to divide the radicands. So now we have root 960 over 120. Now, does 120 divide into 960 perfectly? By that I mean without decimal or remainder. How many times, Nate? 8. That means that this is equal to root 8. And again, I hope you know this, but we don't work left to right. I don't ever want you working when we're simplifying expressions. I don't ever want you going equals, 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 equals. You work down the page from top to bottom. If you are going to work left to right, just draw a single arrow indicating that's what you're doing, but don't put equals. There's reasons for that. All right, are we done here? No, because root 8 is simplifiable. How many of you know immediately, without much thought, that root 8 is 2 root 2? Okay, that's kind of a fairly standard one. Root 8 is root 4 root 2. Root 4 is just 2. So this is 2 root 2. We're building up to something, so I don't want you to believe that this question would even survive the test of being an exam question. You're not going to have an exam question that says simplify root 960 over 120. But it's 2 root 2. Negative 7 root 256 over 14 root 32. Well, this means that we can divide the coefficients and we can divide the radicands. Does 32 divide without remainder into 256? It does. And the first set of questions we're doing will always work out that way. Jay, how many times? Is it 8? Okay, so we end up with negative 1/2. I just divided 7 by 14. And at this level, when you divide numbers that do not divide nicely, like 7 divided by 14, you reduce them to lowest terms. Is everybody clear where the 1/2 came from? 7 over 14 is a half, and it's negative. And you said 8. Notice when I write this, I would like you to try to write it this way. There's nothing wrong with writing this, but it's better if you put the root 8 as a numerator rather than kind of halfway between the top and the bottom. And we can simplify this. Negative 1 over 2, root 8 is 2 root 2. And we're back to, we talked about this before. Can I cancel those 2's? This is my poker face. I'm not. Yes, you can. Jay is going to tell us why we can cancel the 2's. It's multiplication on the top. And I've asked you that, I picked on you because you've answered that question before and you've answered it by saying there's no plus or minus anywhere. I know you've done that. And I've kind of said, yes, that's true, but the big picture is it's multiplication. It's multiplication. That's the perfect answer. That's telling us, if it's multiplication, that these two things are factors and you're allowed to cancel factors. So what are we left with? We're left with negative root 2. Turns out that entire expression is equal to negative root 2. Any questions with B? Right. C. Well, again, what we're doing is we're going to end up dividing the coefficients, and there's lots of ways to write this. This time I'm going to put them in their own set of brackets. And then we're dividing the radicands. 432 r to the 5 over 72 r cubed. So you divide coefficients with coefficients, radicals with radicals. And again, when you divide the radicals, you're dividing the radicands. 80 over 15. I don't think that divides without remainder, but it certainly reduces down. I believe they're both divisible by 5, and I get 16 over 3. Am I alone on that? That's good. 16 over 3. So the new coefficient of this beast is 16/3. Does 432 divide by 72? Is it 6? It's 6. Does r to the 5 divide by r cubed? What is r to the 5 divided by r cubed? Page? R to the 2. And again, look where I wrote them. It's not that big of a deal, but this is really just over 1. So we kind of unwind things now here. We have 16 over 3, and it's the square root of 6r squared over the square root of 1. I really don't believe you need to write this, but that's what it is. And the square root of 1 is 1. So on the bottom of this, we have 1 times 3, which is still 3. This is where we are at. And again, I hope everybody sees that these two things are just the same thing. I don't even know that we needed to rewrite it that way. But are we done? No, because there's something underneath the square root that can be square rooted, namely the r squared. Or you can think of it as under the square root we have r times r. We've got two r's. So we remove them and put a single r outside, and we get 16 thirds r, or 16r over 3 root 6. And that's the answer. Now we have to move on to something that's more complicated. And it's going to get more complicated even next week. To simplify an expression that has a radical in the denominator, you need to rationalize the denominator. What does that mean? Okay, so if I were to take a look at this expression, if you want to write this down, you can, but it's not in your notes. This expression is a radical expression. It contains a radical. But there's a radical in the denominator. So to rationalize this expression means to remove the radical from the denominator. And I hope you can appreciate that removing the radical from the denominator does not mean you do this. Right? You don't just erase it and ignore it. What removing the radical from the denominator means is we have to change the appearance of this so there's no longer a square root there. And there are reasons for this. If I told you that it turns out that 5 over 2 root 3 is the same as 5 root 3 over 18, I better just double check that, my mistake, is the same as 5 root 3 over 6. Let's do this on our calculator. Just trust me on this. You'll learn how to determine this in a second. And be very careful here, because if I do this, watch what I'm entering here. 5 divided by 2 square root 3, that is not going to figure out what 5 over 2 root 3 is. Because that's going to take 5 over 2 and then multiply by root 3. I need to do that. That 5 over 2 root 3 is approximately equal to 1.44 something. Now if I figure out what 5 root 3 divided by 6 is, if I go 5 root 3, close brackets, divided by 6, I get the same number, okay? So you can trust me that they're equal, and we're going to learn how to get from one to the other. Why is it that we want to be able to go from here to here, or why is it that we're not supposed to have radicals in the bottom? I can tell you the best reason is if you go to higher math, like Math 30 or calculus, it leads somewhere. If you get rid of the radical, it solves problems that you can't solve until you get rid of the radical, okay? The old school reason is that it's more difficult to divide by a square root than it is to divide by a whole number. Even if you knew, everybody, even if you knew that the square root of 3 is approximately 1.7. So even if you knew that, and even if you knew that 2 times 1.7 is 3.4, it's more difficult for you to wrap your head around 5 divided by 3.4 than it is to figure out what this is and divide it by 6. We are more capable of dividing by whole numbers mentally than we are by decimals. Okay, that's the main reason. But going back to the beginning, how? So I've explained to you what rationalizing it is. How do we do it? If the bottom of the expression is a monomial, then you accomplish this by multiplying the top and the bottom of the expression by the radical that you want to get rid of. What does that mean? Well, let's go back to this example. What's the radical on the bottom that we want to get rid of? Root 3. Well, you multiply the top and the bottom by root 3. Who can tell me why I'm not changing the value of this expression at this point in time? Why am I allowed to just multiply something like that? Go ahead. Okay, I'm doing the same thing to the top as I am to the bottom, and that, in fact, is a rule we've learned. You can do that. But why? Why does it work? Jay? That's not the real reason. I know what you're thinking, but I'm looking for something that's even more to the point, I guess. Can somebody tell me what that thing that I've written in red, what is root 3 over root 3? It's 1. We're multiplying that expression by 1. And when you multiply by 1, you maintain the value. So what do we get then? What do we get on the top? We get 5 times root 3. On the bottom, we get 2 times root 3 times root 3. Owen, please don't get ahead of us. Thank you. So we end up with 5 root 3 over 2 times 3. Why times 3? Because that root 3 on the bottom times the root 3 is root 9, which is 3. So I end up with what I told you we end up with. Okay? All right, let's try some examples now. I forgot to clear this. 20, the root 20 is on the bottom. We have 30 on the top, so we have to get rid of the root 20. Give me a second. I just want to, I thought I had saved this, but clearly I didn't. So, if you blindly follow the rules, which is fine, we have to multiply the top and the bottom by the square root of 20. So what does it give us? On the top, we get 30 root 20. On the bottom, we get 20. You're going to have to come to this conclusion sooner or later. Root 20 times root 20 is 20. You shouldn't need to write root 400 and then go, oh, that's 20. This is the whole point of rationalizing. Root A is A. Now, before I go on, I have a question for you. Why could I not just do this? Why can't I divide the top and the bottom by 10? Gustav?
20 is under a radical sign.
That's right. 20 is under the radical sign. That's not 20, it's root 20. I can't divide coefficients, which the 30 is, with radicals, which is what the root 20 is. All right. Can I now divide the 30 by the 20? Yeah, because they're both coefficients. So now what I have is 3 root 20 over 2. Am I done? No, because root 20 is simplifiable. Root 20 is 2 root 5. And I want to pause there, and I know you get tired of me saying, oh, you need to know how to do this, but you really do need to know how to figure out what root 20 is on your own. It's root 4, root 5, which is 2 root 5. And I think when you're dealing with numbers like root 12, root 18, root 20, root 24, those smaller radicands, converting them to mixed radicals in simplest form should be like that. Shouldn't be a big effort. So I get 6 root 5 because that 3 and the 2 are coefficients. Am I done? No, because 6 over 2, coefficient over coefficient. In fact, I mean, you could have just done that there, couldn't you? You're left with 3 root 5. Now, is that the only path? No. I'm going to show you a different path we can take, but I don't want you to come to any conclusion that one is better than the other. It depends. Sometimes you won't realize you've chosen the difficult path until you're done. Can we do the same question differently? Well, sure. We could take the root 20 and simplify it first. Root 20 is 2 root 5. Now I can divide the 30 by the 2 and get 15 root 5. But I don't want a radical in the denominator, so I'm going to multiply the top and the bottom by root 5. That's going to give me on the top 15 root 5 divided by 5. Because on the bottom, root 5 times root 5 is 5. Root 5 times root 5 is root 25, which is 5. But now the 15 on the top and the 5 on the bottom reduce down to 3. And my argument for trying this first, in what I have in green first, even though you may have to do more steps sometimes, is that you're going to be dealing with smaller numbers right away. We're not dealing with, 30 root 20. We're dealing with 15 root 5. Anyway, let's move on. Let's try another one. The square root of 60 x to the 8 over the square root of 75 x to the 5. Okay, what do we get here? This is as an entire square root for the coefficients, 60 over 75, and then that. Does 60 over 75 simplify? I think it's 4/5. So this is the square root of 4/5, and this is the square root of x cubed. I'm going to write something else down, and I hope that everybody sees the other thing I'm going to write down is exactly the same as in meaning as what I wrote here. And I don't just mean that if I put these two together, it turns into this thing. I mean you could probably just do that without separately writing two radicals being divided or two radicals being multiplied, however you want to look at it. So we're left with that. The square root of 4 is 2. I'm still going to have a root 5 on the bottom. And I have a root of x cubed on the top. How many of you would have simplified the square root of x cubed at this point in time and just written x square root x? Okay, I'm doing that in a separate step. That x cubed under the square root is this, so there is a pair of x's that I can take out as a single x, and what I have then is 2x root x over root 5. X is not a negative number, but I don't care. Are we done? Why not? Right. So now I'm piling more responsibility on your back here. You have to watch out to see if you can simplify radicals, but you also have to watch out to make sure you don't end up with a radical in the denominator. So how do I get rid of that root 5? I multiply the top and the bottom by root 5. And what do I get on the top? I get 2x, those are my coefficients, or my coefficient. Root x times root 5 is root 5x, and on the bottom I have 5. And listen, you can argue that that doesn't look very simple, and I would accept that argument. I would agree with you, but it is the simplified form of that expression. Can we divide the 2 and the 5? Well, we could, but it doesn't divide nicely, so we don't. Is the radical a radical that can be simplified? No. We're done. There's nothing else to do. Let's try one more. Negative 5/8 root 5 over 7r. Well, to make sense of this, I think it's useful to write it this way. I haven't really done anything here. I'm just splitting up the radical into a numerator radical and a denominator radical, which is the rule. I multiply the top and the bottom by root 7r. On the top, I get negative 5 times root 35r, because the root 5 and the root 7r are radicals. And on the bottom, I have 8 times 7r, because the square root of a thing times the square root of the same thing gives you that thing without the square root. Root 11 times root 11 is 11. What do I get here? I get negative 5 root 35r over 56r. Well, how disappointing. Because we can't do anything with it. I mean, that's a good thing, maybe. Does 5 over 56 reduce down? No. Oh, hey, but can't I cancel the r's? No, because one is under a radical and one is not under a radical. That's it, we're done with that one. Ooh, things have changed all of a sudden. Because now, and I mentioned this at the beginning, we are dividing by monomials. I might have implied we were having monomials divided by monomials. If I did, I apologize. We're dividing by monomials, but here we have a binomial in the numerator. That's okay. 14 minus root 40 over root 20. What's one thing wrong with this expression? If you said, well, that's it, I'm done. What's one thing that you haven't considered? Christy?
The radical under the denominator.
Good, the radical in the denominator. We need to get rid of that. Is there anything else that somebody who claims this is simplified ignored? Liberty?
You can simplify the 40 and 20.
Right, I can simplify some radicals. So you can either rationalize first and then simplify, or simplify the radicals first and then rationalize. But if you simplify the radicals first and then rationalize, you may have to still simplify more radicals later. So my question to you is, how many of you would like to, we're going to actually do both, but I'm just curious, how many of you would prefer to take 14 minus root 40, let me write them both down first, over root 20. How many of you want to do this? And then the other option is, how many of you want to take 14 minus root 40 over root 20 and do this? First. So we have option 1, option 2. How many of you would prefer to do option 1? How many of you would prefer to do option 2? Okay. I'm in the option 2 camp. I recognize that if we go with option 2, which is very few people, I'm probably still going to have to simplify some radicals down the road. The reason is, and I'm not trying to convince you to go one way or the other way, when I do this, the numbers get quite big. The numbers get quite big right out of the gate. But most of you said option 1, so that's what we're going to do first. I'm going to get 14 root 20 minus root 800. So this is the difficulty now. You're dealing with 800 over 20. When I multiply the numerator by that root 20, I have to go root 20 times both pieces. Are we okay with that step? Okay. So the 14 root 20 is 14 times 2 root 5, because root 20 is 2 root 5. And now I would definitely go to scrap paper and work on the root 800. But the root 800 came from this, didn't it? Well, there's a 20 and 40. So I have two factors of 20 in 800. In other words, this is root 400 root 2, or 20 root 2. Can you appreciate, though, that the numbers got big? It's not an insurmountable problem, but it makes it more work. So that is going to be 20 root 2. Over 20, which is 28. Root 5 minus 20 root 2 over 20. Question for you guys. In terms of canceling, do you see how this is similar to the result of the quadratic formula? That you can't just cancel this with this. You have to reduce all three down. Or better yet, I can factor out of the top a 4 and have 7 root 5 minus 5 root 2 over 20, and now the 4 over 20 can reduce down. When I said at the beginning of the class, things are going to pile up, you can see them piling up right away in this lesson. So 4 over 20 is 1 over 5. I end up with 7 root 5 minus 5 root 2 over 5. That's the answer. What if we did what Craig and I wanted to do at the beginning, which is to simplify those radicals first? Well, right out of the gate here, I don't know, Craig, do you see you can do some canceling? We can factor a 2 out of the top. And be left with 7 root 10, 7 minus root 10, all over 2 root 5. So we're dealing right away, if you do it the other way, with 7 minus root 10 all over root 5. That's pretty good compared to root 800, root 20, all that other stuff. I guess I will do this in green in keeping with my theme. Wow, that didn't work. There we go. So I have 7 minus root 10 all over root 5. I'm going to multiply top and bottom by root 5. I get 7 root 50. Ooh, there's a minus in there. I get 7 root 5 minus root 50 all over 5. We take a look at our answer. It's the same answer because root 50 is 5 root 2. I think it's quicker. And I know I can't claim it's always quicker, but most of the time it's quicker if you simplify the radicals first. You just have to remember, just because you've simplified them doesn't mean you won't be doing more of that later. Final question. 3 root 6 plus 12 over root 18. Let's simplify the root 18 first. Then we're dealing with smaller numbers when we rationalize. So this is 3 root 6 plus 12 over 3 root 2. Just ponder that, please. Just give some thought as to how I went from root 18 to 3 root 2. Yeah.
It's 2 root 18.
Do you have a 2 on the bottom?
Yeah.
Thank you. Are you okay with that? So what we end up with is 3 root 6 plus 12. over 6 root 2, because 2 times 3 is 6. Should we rationalize the denominator right now? Or is there something else we could do? Before I take a response to that question, remember we're getting into an area of high school math where you do things not because that's the next step. You do them because it might be a better step. Ashira.
You could simplify the coefficients.
Right. And Ashira, would you be the kind of person that would just reduce the 3, the 12, and the 6 down by a factor of 3? Okay. So if you're that kind of person, you shouldn't be bothered by me factoring a 3 out of the top to get multiplied by root 6 plus 4 all over 6 root 2, and then canceling the 3 in the 6 and getting root 6 plus 4 in the numerator and 3 root 2 in the denominator. So that's where we're at. This stuff is, it's not for the faint of heart. It's getting complicated, and you're going to need lots of practice with this. I'm now going to multiply the top and the bottom of this expression by the square root of 2 to rationalize the denominator. When I do that, I have to multiply that root 2 by the root 6 and get root 12 plus 4 root 2 all over, this is going to become 6.
Shouldn't it be 2 root 2? If you pull the 3 out of the 6?
Oh, yeah. This is a 2, not a 3, right? Thank you, Paige. The 3 over the 6 is 1 over 2. Good. So we end up with, on the bottom, 4, because root 2 times root 2 is 2, times the other 2 is 4. And root 12 can be simplified. This stuff sometimes, and I know the feeling you're going to have, it's like, oh man, is this going to end? Because right now you're at root 12 again. Out of nowhere there's a root 12, which is 2 root 3. Are we done? No, because you can still cancel. I can take a 2 out of the top and have root 3 plus 2 root 2 over 4. This 2 and this 4 reduced down. Got it right this time, to a 2 on the bottom, and root 3 plus 2 root 2. Just to, well, let's take a break here and look at what we had to do to get there, okay? You're going to make mistakes. We all do. But you want to try to minimize them, so you want to go slow. The other thing to note is that this 3 root 6 plus 12 over root 18 on an exam, and this, I admit, this would be a difficult question on an exam. I could give this to you and say, in simplified form, it is a plus b root c over d. What are the values of a, b, c, and d? Because, and I hope you can appreciate this, I don't think I would give this as a multiple choice question, because you can just put that in your calculator and put choice A in your calculator, and if they're equal, it's answer A. Right? That's the Mr. Way method of passing high school math. That's what I did a lot of in high school. I knew how to do it the other way, but it was just quicker for me this way. We don't allow that anymore. Very rare. Anyway, you're going to need practice with this, as I said. You are going to make mistakes. You want to minimize the mistakes by being thoughtful, deliberate, not finding yourself on autopilot. And I know I should model better behavior, but sometimes I just get on autopilot and I'm talking and thinking and writing. You have to be focused. Okay? On page 8, there's a variety of questions for you to practice.